Hi students, welcome back. It's Mrs. Brunk again with geometry, and we are going to be continuing looking at angles that are formed by lines. And specifically in today's lesson, we're going to be looking at parallel lines. And then, of course, you might think, well, parallel lines don't intersect, so how do they make angles? Well, they don't. But with a third line called a transversal, they make some special kind of angle pairs that we're going to define and learn some special relationships that exist when lines are parallel. So I use the word transversal, and that's part of our learning goal. You will be able to identify an angle relationship formed by two parallel lines cut by a transversal. So what is a transversal? We're going to learn that. And use the properties of the relationships to find angle measures. So a transversal is a line that intersects two coplanar, meaning in the same plane, lines at two different points. So transverse means to cross over, okay? And it's going to cross over two lines that are in the same plane in two different points. So you'll see there's a drawing over here of a transversal T. So T is the transversal in this drawing right here, and you can see it's crossing over those two lines in two different points. So it meets the definition of a transversal. So anytime two lines are intersected by a third line, a transversal, 8 angles will be formed. Okay, so you can try it with really any way that you're going to get these two lines to intersect this third line. But 8 angles will be formed, and some of these angles are have special names and they're special relationships. And there's an even more special relationship when the lines that form them are parallel. So the first type of angles we're going to look at are called corresponding angles, and corresponding angles lie on the same side of the transversal and on the same side of the intersected lines. So corresponding means same relative position, and that's what we mean when we say corresponding angles. So they're like in the same position relative to the lines that form them. So for instance, angle 1 is on the left of the transversal and above line P, and 5 is in the exact same position but relative to the other line. So it's on the left of the transversal and above. So those are considered to be a corresponding pair of angles. And there actually are other pair here. There's actually 3 other pair. We could say, so we could now say 2 and 6. So you could put angle 2 and angle 6 are also corresponding. Let's see, my eraser's awfully big. See if I can fix that. There's 3 and 7. Now they're both to the right of the transversal and below the other line that forms them. So we've got those. We can put 3 and 7. And then finally, there's another corresponding pair, and that's 4 and 8. So 4 and 8 are both to the left of the transversal and below. So 4 and angle 8. So there's actually 4 pair of corresponding angles. Now the next special pair of angles that are formed when two lines are cut by a transversal or intersected by a transversal are called same side interior angles. And same, just like the name says, they're same side, that means same side of the transversal, and interior, and that means between the other two lines. So if we went in between the two lines, P and Q, and then on the same side of the transversal, 4 and 5 would be a pair. And that one's not listed, so we'll go ahead and list that one, 4 and 5. And then on the other side, the one that's listed is another pair, and that's 3 and 6. So see, they're both on the right of the transversal and between the two lines. So interior means inside, so they're inside those two lines and they're on the same side. So that's same side interior. Now the next pair are called alternate interior. So they have the same interior part, but they're on alternate, meaning on opposite sides. And they actually have to be in the opposite position, but interior to the other two lines. So the one they listed was 3 and 5. And if you look at that drawing, you can clearly tell there's another pair that also meets that same criteria, that they're on alternate sides of the transversal and they're in between the lines, and that would be 4 and 6. So angle 4 and angle 6 are the other alternate interior angles. And finally, alternate exterior. So alternate exterior, they lie on opposite sides of the transversal and outside the intersected lines. So you can see 1 and 7 are listed. Okay, and maybe pause the video for a second and see if you can figure out the other pair that's alternate exterior meeting that definition. So pause the video now. So if you said 2 and 8, you are absolutely correct. 2 and 8 are the other pair of alternate exterior angles. Okay, so you may have noticed that in this drawing where we've been identifying all these angles, that there's these little arrows marked on them. And I'm not sure if we've talked about this or not in prior lessons. It's hard to remember when we've done stuff. But those little arrows on those lines mean the lines are parallel. Now, just because the lines are parallel here, that doesn't make these angle pairs. Like, even if those lines were not parallel, those angles would still be called corresponding angles. But there's a special relationship that exists with those angles when the lines actually are parallel. So you'll see when lines have those little arrows on there, matching arrows, that's a way of saying they're parallel. So it says, recall that parallel lines lie in the same plane and never intersect. In the figure, line L is parallel to line M, written L with the 2 vertical lines, or sometimes they're slanted lines, like hashtags. And that's a way of writing out symbolically that 2 lines are parallel. And the arrows on the lines also indicate they're parallel. So like I said, these little arrows right here are a visual way of indicating that lines are parallel. So our first postulate we're going to learn is called the same side interiors angle postulate. So we talked about same side interior angles, and let's take a look over this drawing and see if we can identify a pair of same side. Remember, same side of the transversal and interior to the 2 lines that are intersected by the transversal. So one of the pairs would be this pair, or this one right here, 3, and this one right here, 6. Those are same side interiors. Well, so when we think about special relationships in terms of angle measures, you might think, angles that are equal, like vertical angles. Well, that doesn't appear to be the case here. These are clearly not equal measures. And then we learned about complementary angles. Well, clearly these 2 angles are not complementary because we have one quite large obtuse angle in 3, and then 6 is an acute angle. So they definitely are more than 90 degrees. But the other special relationship with angles we learned about was called supplementary angles, and supplementary angles added up to 180, and that's actually the case here, that when you have parallel lines, the same side interior angles will always be supplementary. So that's what this says right here. So if 2 parallel lines are cut by a transversal, then the pairs of same side interiors are supplementary. So the ones on the other side, 4 and 5, they also add up to 180 degrees together. So that's that first relationship that exists when 2 lines are cut by a transversal. Same side interior angles are supplementary. Now looking at the other angle pairs, so we had alternate exterior, and alternate exterior, remember, were the ones on the outside and then on alternate sides of the transversal, like say 2 and 8 and 7 and 1. Now if you take a look at those pairs, it looks like 8 and 2 almost looks like, if you kind of slide them together, they look like vertical angles. Like you could put, slide the one section on the bottom up, and you could create like vertical angles there. And that actually, the same relationship holds. That alternate exterior angles are always equal if the lines are parallel. That's what this theorem says. If two parallel lines are cut by a transversal, then the pairs of alternate interior, oops, that's supposed to say alternate exterior. Oh, I'm sorry, I was doing the wrong pair. I was doing alternate exterior. That's actually next. Sorry about that. So let me erase. I misread that. Alternate exterior is on the next one. These are alternate interior. I misread. So alternate interior would be like your 4 and your 6 and your 5 and 3. And what this says is still the same relationship as alternate exterior, except for it's saying that the alternate interior angles are equal. So I could mark these as being equal. I could say angle 4 and angle 6 are equal. So angle 4 is congruent to angle 6. But then also these angles over here, 3 and 5, are also equal to each other. Angle 3 is congruent to angle 5. So notice when I have more than one pair of angle pairs that are equal, I just change the kinds of markings I put on there. So to show that 4 and 6 are equal, I use the single arcs. But to show that 3 and 5, because they're different measures than 4 and 6, but to show that 3 and 5 are equal, I used double arcs. That's kind of the typical way that we would show that on a diagram, is just putting matching arcs. So alternate interior angles are congruent if the lines that form them are parallel. Now that would not be the case if the lines weren't parallel. So let me just show you real quick. Draw a picture of just two lines, and these two lines are not parallel, clearly. This is a transversal. So if I looked at this angle right here and this angle right here, so those are alternate interior angles, but they certainly are not equal in measure. They don't look like they're really very close at all. Like this pair right here, I mean, the one up top, the higher one, is much smaller acute angle, whereas this one that's lower is much bigger. And we could even make that even more extreme. We could make the lines even more extreme and not intersecting, or not parallel, like this. Say like this. And then you can definitely see that the alternate interior angles are not equal. So like this one right here is quite small, this one quite here much bigger. So this relationship with the angles being equal is only true when the lines are parallel. They're still called alternate interior angles when the lines aren't parallel, but they're just not equal in measure. Now what about corresponding angles? So remember, the corresponding angles were the ones that are in the same relative position. So like say 1 and 5, those are corresponding. And 2 and 6, and 3 and 7, and 4 and 8. And hopefully what you noticed as I was highlighting those, each time those angles look to be about the same measure. And in fact they are. That's what corresponding angles theorem says, is if two parallel lines are cut by a transversal, then the corresponding angles are the same measure. So we could say angle 2 is congruent to angle 6. We could say angle 3 is congruent to angle 7. We could say 4 and 8 are congruent. And finally, we could say 1 and 5 are congruent, because those are all the corresponding angle pairs. So as long as these lines are parallel, these pairs will be congruent. And now our final angle pair, the alternate exterior angles, those were the ones I mistakenly was explaining with the prior theorem, but that's 2 and 8 and 1 and 7. And again, if you just had to look at the drawing and say, a guess that what the relationship is, they're definitely going to be equal. So 2 and 8 look like they're congruent, and they actually are, and how I can justify it is this alternate exterior angle theorem. So alternate exterior angles are the same measure if they're formed by two parallel lines cut by a transversal. So I could say angle 1 is congruent to angle 7, and I could also say angle 2 is congruent to angle 8. So now we're going to move on and actually apply these properties to find some missing angles. So our directions are to identify the angle relationship and then use the properties to find the value of x. So first of all, we're going to take a look at the angles that are labeled and see if we can figure out what type of angles that they are. And clearly you can see in every one of these examples that the lines that are intersected by the transversal are parallel because they got those little red arrows on them to show that they're equal. To show that they're parallel, excuse me. So now looking at these angles, we have this angle right here that's labeled. Oops, I didn't mean to cover that up, this one. And this one. And hopefully you identified these as alternate interior angles. So look back at the alternate interior angles theorem. It says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So that's what we're talking about here. We're talking about these two angles, and we're saying that they must be equal in measure. So if I wanted to mark that on the drawing, I put a little like arc here in the corner. So for my stylus isn't working. So let's try that again. And nope, there we go. And I'm trying to put a little arc there, but it's not going to work. There we go. And so I can apply the alternate interior angle theorem. Oh, and by the way, I usually like to abbreviate these. These are long ones to write. So if you want to state a property that you're using, I use these shortcuts. For alternate interior angles, I use A congruence theorem. So that's alternate interior angle congruence theorem. Same side interiors, I use SSI, same SSI theorem. The corresponding angles, I just do C corresponding angle, and then theorem THM. And then finally, alternate exterior angles is AEA congruence theorem. And it's helpful to have abbreviations because we'll be writing some proofs, and it just shortens up what you have to write for the proofs. So anyway, I know these are equal, so I'm going to say that. I'm going to say 5x minus 10 equals 50. And to solve, I'm just going to add 10 to both sides. And that leaves me with 5x equals 60. Oops, 5, not 50, but 5x equals 60. Divide both sides by 5, and I get x is 12. So that's all they asked me to do, was to find the value of x. If I wanted to, I could take 12 and plug it back in here, and then I'd be able to show for sure that that measure is 50 degrees, because 5 times 12 is 60 minus 10 is 50 degrees. But all they asked for here is just to tell what the value of x was, and there it is. X is 12. And again, we're applying the AIA congruence theorem. So we want to state the property. So it says, so identify the angle relationship and use the property. So the angle relationship is they're equal. The property is the AIA congruence theorem, and x is 12. Now this next example, we've got these two angles out here. These are the alternate exteriors, right? So applying the AIA, AEA, we could say that these two are congruent. We could say 8x plus 9 is equal to 10x minus 5. And to find the value of x, we're just going to try to isolate the variable on one side. So my first step, doesn't always have to be this first step, but this is how I do it. I'll move the variable first. So I'm going to subtract 8x from both sides, leaving me with just 9 over on the left, and 2x minus 5 on the right. Then adding 5 to both sides is going to give me a value of 14 on the one side and 2x on the other. And that means that x has to be 7. If I divide both sides by 2, I'll get 7. So the property is the AEA. The value of, or the relationship is the angles are equal, and the value of x is 7. So looking at C, this time, these are the angles that are labeled. And it definitely does not look like they are equal. I mean, even just thinking about it, even though there's no looks like it theorem or anything, but just looking at this, I can tell that the one angle is clearly acute, that's 17x minus 5, and the other one is obtuse. So to say they're equal doesn't even make logical sense from the picture. But that other relationship that existed was with these same side interiors is that they were supplementary, or they added up to 180 degrees together. So using the same side interiors theorem, we could say that these add up to 180 degrees. So I could say 20x plus 17x minus 5, minus 5 equals 180. And then I could just solve that equation for x. So putting my like terms together, the 20x and the 17x combine to make 37x. And then if I just go ahead and add 5 to both sides to get the numbers without variables on the same side, that's going to leave me with 185 on one side and 37x on the other. And if I just divided both sides by 37, which would be my undoing of the multiplying by 37 is dividing, I'd end up with just x being equal to 5. And then I could verify that, in fact, these two angles do add up to 180 by substituting them back in. If I put 5 into the 20x expression, I'd get 100. Put it into the 17x minus 5. 17 times 5 is 85, minus 5 is 80. So, and then 180 is 180. So here's where we're going to have this one be a U try. I want you to see if you can identify in D what kind of angles these are from the angle pairs we studied. Identify a relationship there, and then solve to find out what x is. So go ahead and pause the video now for your U try question. Be sure to state the property you're using as well. Thanks for giving that one a try. Those were corresponding angles, and since the lines are parallel, we know these have to be equal. And they even look equal. I mean, you just can imagine the one angle sliding it up and putting it right in that spot of the other one. And in fact, we do have a theorem to support that. Not just that they look alike, they actually are equal. And the value of x is 9. So for our final example, we're going to take a look at a diagram that is supposed to be sort of a diagram of some roads. And we're told that roads A and B are parallel. So these are parallel lines that are cut by a transversal. So another line, another road that crosses both, like a cross street, would be the transversal. And so we have all these same angle pairs that are formed. So if we look at the two angles that are labeled here, you can see that this angle right here and this angle right here are in the position of alternate exterior angles. And since they tell us that the roads are parallel, so these are parallel here, we know that by the AEA, alternate exterior angle congruence theorem, these have to be equal. So that's x plus 40 would have to equal 2x minus 22. And we're going to leave these, this solving of this to you for your U try that we'll check in on when we get to class and just find your value of x. So just to find the value of x will be your task for your U try. And then also to find the measure of angle VTU. So you're going to go ahead and take x when you find it and substitute it back in. So I'm going to have you do those, and I'm going to help you set up B, and we'll leave that one for you to finish as well. So looking at these two angles, we've got our parallel roads here, A and B, and then we've got that other road that transverses or crosses these two. And the angles that they measure, or that they've labeled here, now if you kind of take a minute to sort of analyze where they're positioned, there's not a special relationship that we learned about for this type of angle. Like, these are not alternate exteriors because they're actually on the same side of the transversal. But these are actually on the same side and exterior. And actually the same relationship holds here as does for the same side interiors. So I've seen some textbooks that actually list this as a separate property. It's called the same side exterior angle theorem. And we actually would know that the same relationship holds as same side interior, that these add up to 180 degrees together. And the reason why is you could say, well, this angle right here, 22x plus 25 is the same as this angle right there because they're corresponding angles. And then because then these angles right next to each other make a linear pair, they have to add up to 180. And so there's just a clear logical connection there to make this claim that these two angles add up to 180 degrees, or are supplementary. So I could say 9x plus 22x plus 25 equal 180 degrees together. So there's another one I'm going to leave you to finish. Find out the value of x and find out the measure of angle WUV in this one. And these will be some answers that we'll check back in when we meet in class, and just to kind of do a check that you made sure you wrapped up the lesson and tried some of these independently. So this leads us to the end of our lesson. Wrap up and finish these two questions so you have these answers when you come to class, and thanks for learning geometry with me today.